Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to all of you once again to the physics classes. Dear students, we were talking about competitive exam classes. In that we were talking about chapter called atom, and some of the concept maybe like the two models of an atom we have seen. Maybe it is Bohr's model or Rutherford model, what the ancient stages they have done and the formulas of that, and related to that what are all the questions may come. So mainly whatever we have studied in the first part of the synopsis, we are going to get only conceptual questions, and maybe we have discussed about time period, frequency, velocity, energy, frequency, velocity, all those things, the concepts and some points you have to find out. Okay, and today in this class we are going to talk about the formulas, some kind of formulas of energy. Okay. So we know that generally according to the Bohr's model, nucleus is there, electrons are revolving, and we will say it is the first level, second level in that way, isn't it? So this is the ground state, n is equal to 1 we are going to call it is. This is the first excited state, second excited state, n1, n2, n3, n4 in that way. Okay. So excited state means before coming to the excited state or before coming to the energy expressions, all those things. So what we have studied, that is something about radius, velocity, all those we have studied. Okay, but another thing we have studied is that, see, when electron is bound, electron is bound to that nucleus, there is a electrostatic potential which will provide the centripetal force. So that it is bound. When it is bound means there is a force, means there is a energy. Energy means nothing but work done means energy, that you have to remember. Okay, so work done is a scalar quantity, energy, wherever you have to find out the energy means you have to find out the work done, energy, like that. If work done you have to find out means energy automatically you are going to get. Now here also energy is there, some energy is there for all the bound system. Electron is a bound system, as you have studied in your first year. Same for first year you have studied for satellites, okay, or planets. Okay, there you have studied what, again a planet is bound to the attractive system, that is a planet is there and the satellite is which is bound, which does not allow to go away from that, that is from gravitational force. Similarly here also there is attraction force, because it is a positive charge, is it negative charge, and for that pull it is rotating, and there is a centripetal force provided by the electrostatic force of attraction. Okay, and there is a bound system, energy comes, that is the thing, but because of that this is a bound to that nucleus. Bound system means energy comes as negative, so it is having two energies, since it is revolving means it is having kinetic energy also and electrostatic potential energies also it is having. So what is that kinetic energy? Kinetic energy we are going to write down half mv square. Half mv square means we have discussed, we have studied in the last class, that is v square you have to substitute, so that you are going to get half mv square is nothing but which is equal to ze square divided by 1 by 4 pi epsilon naught and 2 rn you are going to get. So Rn again you have to substitute, and if you substitute all those things you are going to get potential energy as, kinetic energy as 13.6 eV. Kinetic energy as 13.6 eV into z square divided by n square, in that way, where z square and n square is varies. This is in terms of electron volt. Now what is potential energy? Potential energy is also, we will denote it with the U, okay, and that will be actually twice that of the kinetic energy, that actually twice that of the kinetic energy, which is equal to ze square divided by 1 by 4 pi epsilon naught Rn, 4 pi epsilon naught Rn So twice means, and it is negative, that of the kinetic energy, 27.2. You are going to get 27.2 z square by n square, z square by n square. It is also in terms of EV. Okay. So this is also varies for other things, or different atom, it is varies. And total energy is nothing but the sum of that. So if you add it, total energy is going to become negative. Total energy is going to become negative. Why? Because that electron is bound to the nucleus, that is having negative energy. It is not having any positive energy, so that it can escape. Positive energy means it can go anywhere free, or zero energy means it is free. Now negative energy means it is bound. Okay. So electron nucleus is going to control that electron, nucleus is going to control, it is going to bound system, and you are going to get the energy is minus 13.6 z square by n square, z square by n square EV. So this is the case of total energy. Now for the competitive exam, what you have to study? There is a question, no? How I have to remember these formulas? What will be the relation and all? So it is very easy. See, this you have to relate, I will tell you, because in the case of gravitation also, in the case of nuclear physics here also, energy concept is same, that bound case 2 times 1 time like that and all. Expression little bit changes, and there is only attractive force was there, here a repulsive force and attractive force will be there like that, but for the bound system same kind of cases comes. Now what actually the relation you are going to get? See, total energy or kinetic energy, if you write down, means kinetic energy is equal to potential energy. Kinetic energy is equal to potential energy, but it is negative and it is 2 times, isn't it? If you multiply 2 times to the kinetic energy, you will get the potential energy, but negative. And again, kinetic energy same as that of the total energy. Kinetic energy is same as that of the total energy, but it is negative. This formula you have to remember, and these things you have to remember. That is nothing but for the total energy and kinetic energy, that is 13.6. Okay, in that way. Now Bohr, because of Bohr's expression we got this, and based on this total energy expression we are all getting other datas, right? That is we know that using Planck's equation, E is equal to h nu, isn't it? H nu is nothing but frequency, E means, that is h nu is nothing but the frequency of radiation or energy of radiation in which it is going to emit. Now I said that, see, you also know that is nothing but in orbit, electron jumps to another orbit and comes back to its original state, then it going to emit radiations, all those things. That radiations will be the difference in energies, okay, and that is h is equal to nu, right? Now what energy we had? The total energy of an electron when it is going to orbit around a nucleus, maybe it is in the first orbit, second orbit, third orbit, whatever it may be, that is depends on n square. So we have written that minus 13 only for hydrogen, we have written minus 13.6 z square by n square, and what we have written for the first case, that is for hydrogen first orbit, is z is 1 and n is 1, we are going to get minus 13.6. means if you have hydrogen and the first electron which is having minus 13.6 electron volt of energy, okay. So I hope you know that how to convert electron volt and joules. That I am not going to discuss once again here, because already in electrostatic we have discussed there, okay, divided by 1.6 into 10 to the power minus 19, all those things, okay, and you should know the relation between that. Now what we were talking about? Yes, when electron is revolving, in that it is having this much of energy. Now I have to make it free. It is having negative energy, I have to make it free. What I have to do? I have to add plus 13.6 EV, isn't it? Then energy becomes 0. Energy of an electron becomes 0 means it is free. Positive means because of positive it will go somewhere. Now it became free. It become free means it is become free from this. And when we are going to talk about this kind of scenario, that is nothing but when you make an electron a free, that is nothing but ionization energy, right? That is nothing but ionization energy is nothing but energy, minimum energy required to remove an electron from the outermost orbit, right? And this is what the ionization energy, and the different orbit, it becomes different. Why? Based on your n square as well as another things, that is nothing but n square and z square, it is different, it varies, okay. That is what ionization energy is. For the first orbit it is like that, and mainly we are going to concentrate only about hydrogen, because Bohr gave everything for hydrogen. So hydrogen first orbit, all those things, and it is studied only for hydrogen atom, okay. Now this is what the expression, so that we get hydrogen spectrum. Later we will study about hydrogen spectrum, isn't it? So before I want to say about potential. Potential means, see, I am having hydrogen, I have to take out an electron, I can apply electrostatic potential and I can eject an electron from the outermost orbit of hydrogen. Now what I have to do? I have to apply a potential. How I can calculate that? Potential meant what I said. Potential energy means everything is expression comes of work done. Okay, work done. Work done is nothing but, sorry, because before potential is nothing but work done per unit charge, no. Work done per unit charge. Work done means what? Energy. Work done means energy. Energy divided by unit charge. What is charge? Charge of an electron is not Q, it is E, isn't it? Now I want ionization potential. Ionization potential means V, that is ionization potential, that is the minimum potential I have to apply for an outermost or first orbit of an electron, so that I can eject that electron, which is nothing but ionization energy, which is nothing but ionization energy divided by the charge of the electron, right? Ionization energy divided by the charge of the electron. Now see, ionization energy is which, how much? For the first orbit means 1 and 1 I am going to put, and for the second orbit means 1 and 2 I am going to put, because Z is 1 itself, no. So ionization energy is minus 13.6, ionization plus I am going to put, okay. It is just a positive energy I have to give, so that it becomes 0, total energy of that, okay. So 13.6 Z square divided by N square, it was EV, so I am divided by EV, so what actually E cancels, so that I can get here it is 13.6 Z square divided by N square volt. No, this is what ionization potential is. Ionization potential is. And after that we are going to talk about spectral series. Actually when Bohr gave his model of an atom, the main question was to explain the hydrogen spectrum. Main question was to explain the hydrogen spectrum, and for that based on Bohr's atomic model and his configurations or formulations or whatever the thing he has given, maybe formulas, radius, energy and all, different scientists worked out and they found different series of hydrogen. And we also know that there is a Lyman series, Balmer series, Paschen series, Fund series, no, bracket series. So these are the different scientists, they are using Bohr's concept, they have found of hydrogen spectrum. And whenever we are going to get all those things, for that we are going to write down the energy level things, no. So n is equal to 1 means it is ground state, we are going to write down, means electron in the ground state, it is not at all having a positive energy, negative energy, some energy, bound state energy is there, it is not at all absorbed any energy. Next n2 is nothing but another state, next orbit, no. So that is n is equal to 1, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, right. Now see, electron absorbs energy and goes to the excited state. So this one is called first excited state. So when they will ask the question, they will say first excited state, second excited state, third excited state. Remember, first excited state means not n is equal to 1, n is equal to 2. Second excited state means, remember, okay, what is that? N is equal to 3, not n is equal to 2. That you have to remember. But this is the energy level. Now first energy level means what? N is equal to 1 itself. Energy level is n is equal to 2 itself. First, second, third, like that. But whenever they are going to say ground state, because ground state is not a excited state, right? The first excited state is this, second, third. Okay. So third in this case. Now, okay, this one absorbs the energy, goes to somewhere and comes back. It may come from immediately n is equal to 2. It may come from immediately after n is equal to 3. It may come from n is equal to 4, or it may come from n is equal to 5. Now all the electron which have gone to the highest state, I don't know, maybe it is n equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. But we know that it must come to n1, okay, or the ground state by emitting whatever the energy they have absorbed. And if they are going to come for the n is equal to 1, then which series or which spectrum you are going to get? Some ultraviolet spectrum you are going to get, and which is detected by Lyman. So it called as Lyman series. Similarly, if it is comes from higher energy state to the n2, that becomes Balmer series, and it is in visible region, Lyman series, Balmer series. So again like that only we have studied, no, Lyman, Balmer, Paschen series, bracket series and Fund series. But we are not much interested in the diagram. That all those things we have discussed for our board examinations. But we are interested to write down that formula so that we can work out what is the wavelength, what is the wave number, what is the frequency, what is the velocity of the electron in that orbit. All those questions will come. Now Rydberg constant, by taking all those formulas, we have got one equation for the energy state. Okay, what is that? That is nothing but 1 by lambda. This is nothing but wave number. What do you mean by wave number? Wave number is nothing but number of waves in 1 meter, number of waves in 1 meter, okay, which is equal to z square r into c and 1 by n1 square minus 1 by n2 square. This is the formula general, but z square for hydrogen we are going to take it as 1, okay, so that we will get only r, okay, we are going to get only r, that r and c we are going to get the constant, okay, c won't come there, it is r into this formula will come. Now for the Lyman series, okay, we will write down the expression. So wave number, from that wave also you can find out. So Rydberg constant, what is the expression? You have to remember 1.09 into 10 to the power 7, okay, 1.09 into 10 to the power 7 per meter, okay. The SI unit is per meter and the value is 1.097. So for Lyman series means I am talking about maximum wavelength and minimum wavelength. See, it has to jump to n1 from infinity, that is the minimum wavelength, because maximum energy is there, maximum frequency is there. Maximum frequency means minimum wavelength, minimum frequency means maximum wavelength. Maximum wavelength when I will get, immediately from n2 to n1 it is going to jump. So what I have to write down? Maximum wavelength. Okay, remember maximum wavelength I can get only at from n2 to n1, and minimum wavelength I can get, okay, for the maximum frequency, minimum wavelength I can get from that, from infinity to n. So now maximum wavelength for the Lyman series means it is always 1. So n1 is 1,
minus, it is going to jump from maximum wavelength n is equal to 2 to the power 4. Oh, sorry, 2 to the power 2, that is nothing but 4. Okay, so what is the expression I am going to get? 4 minus 1 is 3r divided by 4 I am going to get. So what is the expression? From this you can get the value, so that you have to calculate. And for infinity, that is nothing but 1 by lambda minimum, 1 by lambda minimum, that is nothing but r into 1 minus 1 by infinity square. 1 by infinity is 0, so that will be nearly equal to 912 angstrom. 912 angstrom, that implies lambda is equal to minimum is 912 angstrom. Okay, so this one you have to calculate. This, if you remember, means it is very much easy for you, otherwise no need. Just some of the examples like ratios and all they are going to ask. So minimum maximum for all the series you have to remember, try to remember that. Okay, this is what you are going to get, and this will be in ultraviolet region, this will be in ultraviolet region. Now spectral lines are there, isn't it? Now spectral lines are there. How many spectral lines are you are going to get? So see, from n2 to n1 it is going to jump, means it is not only one line, spectral line you are going to get. What is the meaning of spectral line? In spectroscope, one device is there, you are going to see, you are going to analyze the spectrum. In that you will get different lines or one line, like that you are going to get, okay, practically. So it may get number of lines. Now how to find out the number of lines are there? That can be written as n is equal to n into n plus 1 divided by 2, where n is nothing but the order from where that electron is jumped from the higher excited state to the lower excited state, like that. So this is n minus 1, n into n minus 1 divided by 2. This is for Lyman series. Similarly, for the Balmer series also you are going to write down using the same concept. Now for Balmer series is how much? That is 1 by lambda wave number r into n1 is, that is nothing but 2, because for the second level they are going to come, not for the first level. This becomes 4 minus, for the maximum wavelength, that is here it is 3 square, and for the minimum wavelength means it is maximum frequency inversely proportional. Remember, 2 square minus 1 by infinity, so I can write down only this much. Okay, this you have to calculate. This is a homework for you. Again, when you listen to this class, you write down and calculate this. Okay, try to calculate then, and what is the minimum and maximum frequency you are going to get, that you work it out and write down. So for Balmer series, lambda maximum, verify it whether you are going to get or not. Lambda minimum, so lambda maximum is 6563 angstrom, 6563 angstrom, and lambda minimum is 3636 angstrom. Okay, this value you are going to get. So that is will be in visible region. Visible region means that is the visible light. Okay, nearly 600 nanometer to 300 nanometer, in that way, that visible light. Okay, so different lights are there. This is the thing. Again, we can write down for Lyman series and Balmer series, for the mth and nth wavelength. For Lyman series, the ratios, wavelength of mth order to the wavelength of nth order. Okay, that is same formula. Okay, similar to of that is nothing but m plus 1 whole square divided by n plus 1 whole square into n plus 1, here n plus 1 whole square minus 1, n plus 1 whole square minus 1 divided by m plus 1 whole square minus 1, m plus 1 whole square minus 1. And for the Balmer series, the ratio m into ln you are going to get here also same way, m plus 2 divided by n plus 2. Okay, because second whole square I can write down, both whole square I can write down, separately I have written, here together I have written. Again here comes as where n plus 1 is there, here n plus 2 whole square minus 1, m plus 2 whole square minus 4, because it is 1 square and 2 square it is. Okay, here it is Balmer means n1 is equal to 2, no, here it is 2 to the square, like that it changes. This is for only 2 I have written. It a third series like Lyman series, Balmer series, then Faston series, bracket series, Fund series, like that it goes, it varies. Okay, that is the thing that you should know. When you solve the questions again you are going to get the clarity, and this Balmer series are in the visible region. Just again we are going to write down for the Faston series. I think you can make out the formula for this, that is nothing but Faston series, it is 3 square for the lambda maximum and it is 4 square, and here it is 3 square for the lambda minimum. And again it comes in the which order, that is nothing but lies in a infrared region, it is lies in a infrared region. Okay, so this is what simple thing. So they will ask you to find out the ratios, all those things and all, so see it. Okay, so directly you can use this, or else by using this formula also you can find out. Okay, while we solve this question, the exact picture of this. Now what actually velocity is? So we have say for example for you I have asked to only about hydrogen. Okay, velocity we have studied. For hydrogen you have found the velocity and radius, all those things we have studied. Now velocity expression, so velocity expression is ZE square divided by 2 epsilon naught NH, 2 epsilon naught NH. We were talking about atoms, some of the NEET topics. So we have discussed that atomic spectrum, the line spectrum of hydrogen. Line spectrum of hydrogen means when the hydrogen atom electron jumps from lower state to higher state and it comes back to the lower state, it will emit that energy, and that energy will be given as a radiations, and different that radiation itself, if it goes to the higher state, in this way, that is 1, 2, 3 means from the higher state it jumps back, means it is going to give different series, and that is discovered by different scientists. No, so Faston series, how it is, that already we know that the formula is there. Here n1 that is the first order, and here n2 the second order we are going to put. So Lyman is n1 is 1, Lyman Balmer is n1 is 2, Faston series is n1 is 3, means from any higher order it jumps to the third region, means third order, means it going to emit the series that will be in infrared region, and those are detected by Faston. And lambda maximum means what? Immediate jump is lambda maximum, okay, and infinity jump is lambda minimum. Remember, immediate jump is lambda maximum, means 1 by lambda maximum you have to find out, means that is 1 by 9 minus 1 by, here it is 4, 16. This is lambda maximum, this is lambda maximum. And what is lambda minimum? Lambda minimum means this becomes infinity, so that you are going to left with only this, that is lambda minimum, and it jumps with the infinity. So lambda minimum means frequency will be more. So infinite order, from the infinite order jumps to the ground level, means the frequency is more. Okay, the immediate in the level means goes up, means in that way. So that you have to keep it in mind. Also lambda maximum was written here, go through it, this is one thing. Okay. Second thing, after that we will be having bracket series, same way there is formula will be there. Lambda maximum if you calculate means you are going to get this, lambda minimum you are going to calculate this means 14,572 angstrom you are going to get. You must know this value, that is Rydberg constant, and this also series lies in higher order of infrared region, that IR is same, that is little higher order of infrared region. Okay. So, this is Paschen bracket series, Paschen bracket, and fund series again, that is nothing but for the fifth order they are going to jump, any of the higher orbit electron are going to jump to the fifth order, then you are going to get lambda maximum as 74563 angstrom. Lambda minimum you can calculate by eliminating this. Okay. So, remember lambda maximum means immediate jump, that is 5 means it is 6, lambda minimum means it is from the infinite, order it is going to jump. This was what we have studied in the case of atom, and at the final, at the last, de Broglie gave one explanation. The important thing which was given by Niels Bohr is the quantization of angular momentum. The quantization of angular momentum, that is nothing but mvr into n times h by 2 pi. mvr is equal to n times h by 2 pi. Now, what is mvr? We know that lambda is equal to, isn't it, lambda, that is, this is mvr. Because of the de Broglie wave equation, we know that lambda which is equal to h by 2 pi, h by mv, isn't it? So, this is what this thing, and by substituting both the equations, that is mvr which is equal to, you can find out, you can get that nh by 2 pi. So, how did we get? That is nothing but this value we are going to get. So, how de Broglie said? De Broglie said that if electrons are stationary, okay, in the orbit, they are giving you a stationary waves. It should not be, interact destructively, it has to interact constructively, there must be constructive. So, standing wave you are going to get, a particle is rotating. So, how many? 2 pi r times lambda are there, n lambdas are there, no? Now, lambda means 2 pi r which is equal to lambda means h by mv. So, that mvr we are going to get divided by nh by 2 pi we are going to get, and this is what the equation which is given by Niels Bohr is verified and given the explanation by de Broglie, because Niels Bohr himself he was not knowing that how did he get that equation, that is nh by 2 pi, okay, while doing the calculation of this, and later there was no explanation, later de Broglie gave the explanation. So, that is one formula you have to remember, and this is how we can conclude of the synopsis part of the atoms, chapter atom. Now, this is what you have to go through it, and go through the sum of atoms is very easy chapter. Okay, it is very easy. You will be having only about spectral lines and some of the theories. Okay, that is the thing. So, once again go through it and take any one of the book. I am telling repeatedly, any one of the book, standard book you take and refer, and 10 questions per day you solve. That will be the best preparation you can do. Okay, day by day. That is, and day by day, not only 10, you are going to increase your speed in that way. Okay, this is how I am going to conclude about the chapter synopsis part of the atom. Next, we are going to talk about the questions. It may be 15 questions per sessions,
or maybe 15 or 16 questions per session we are going to talk. Only few questions, the small question, go through it once, okay, and find out the methods, all those things. Thank you very much for watching this video. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.